Welcome to the Computer Security Seminar. Today's speaker is Professor Torsten Braun from the University of Bern. And he will speak on user and machine authentication and authorization infrastructure for distributed test beds. Torsten.
Okay, thanks a lot for inviting me to this seminar and for attending. I have to say that today's talk, it's not too much about security research, but rather about development of a system. And also I have to say that we are not security researchers, but we are rather applying security mechanisms for various activities we are running in our research. And you can also already see it on the title that we have been implementing or designing and implementing an authentication and authorization infrastructure for distributed testbeds, in particular for wireless sensor network testbeds. So we are wireless sensor network researchers. We are doing a lot of research in wireless sensor networks. I will also give a talk on Friday in the CERIAS seminar about that. And for supporting our research, we need testbeds, and we have to protect the testbed from unauthorized use, of course, so that only our students can use them or other people who would like to use, but not in an uncontrolled manner. And for that, we need, of course, authentication and authorization. So basically, I will structure my talk as follows. First, I want to give the background for our work, the motivation for our work, the application area where we are applying our security infrastructure, or authentication and authorization infrastructure. So I basically will give an introduction of the Wisebed project. That's a European project on wireless sensor network testbeds. Then I will introduce some basics about, in particular, the system we have used for authentication and authorization. Basically, that's a system based on a piece of software which has been developed in the Internet2 Initiative or Middleware Initiative in the US, but has been widely deployed in Europe in several research networks, and we are using this software for protecting our testbed from unauthorized use. And after that, I will then show how we combine the two things, this authentication and authorization software and our distributed wireless sensor network testbed. I also intend to perform some live demonstrations, but as you know, live demonstrations are always a little bit dangerous, so I hope it will run today without problems. So here's the context of our application area. So we are currently still running so-called small research project in Europe. It's called Wisebed, Wireless Sensor Network Testbed. And basically there are 9 university partners who share their resources. That means the idea is that we have at different universities here different wireless sensor network testbeds. So we have, for example, in Bern, we have deployed our own wireless sensor network testbed, but we want to make the testbed available to other researchers, since, for example, we have a good number of T-Mode Sky nodes and MSB nodes, but other researchers might not have the same resources, and also our colleagues in Germany, they have some sunspot nodes, but we do not have them. And if we have developed some algorithms running on our nodes, we want to test them on other infrastructures. Therefore, we think that sharing resources is quite a good idea. Not everybody has to deploy several different test beds, but just can focus on one or two. And if there's a need to use other test beds, we just access them over the internet. So basically, this ends up in a federation of wireless sensor network testbeds. Each partner runs their own testbed with different hardware, heterogeneous hardware, and the requirement, of course, is now we need some kind of access control mechanism so that authorized users, for example, of this project can access all the resources whenever they like, or if, for example, you have the need to experiment with sensors, you can ask us, and then we can also give you some access. So for example, we started with the project partners, of course, but in the meantime, several other universities, Cambridge, some Brazilian universities, for example, also can access this testbed, of course. Then you need some kind of access control mechanism. So, of course, we do not like to have situations where just everybody in the world uses our testbed, and my students probably begin to complain that they cannot do any more reasonable work. So we need to have some kind of control on the resources. So here you see a rough overview of the testbed infrastructure. So we have these different universities, for example, Lancaster, Geneva, Berlin, and so on. And each partner now has a center network testbed, and of course then we have to interconnect the testbeds so that everybody can connect to any other testbed via the internet, and therefore we have here so-called portal servers. Portal servers are just Linux boxes or even a virtual machine running on a computer which has the requirement, or which should fulfill the requirement of protecting the center network from unauthorized use. So basically it's also a gateway interconnecting the center network testbed to the internet, and we just establish here an overlay network in order to interconnect the various sites of this distributed or federated testbed. So here a closer look to a typical testbed site. So again, you see here the internet and the portal server, which is a gateway, and then we have the wireless sensor network testbed consisting of various wireless sensor nodes which are communicating with each other over a wireless interface, of course. So these are basically the main components, and then we have here another one, and the internet connects all the different testbeds together. So here you see one example of a testbed. Of course, I took the one from Bern. So that's our building, and you see a similar structure here, a user interface where you see all the different sensors distributed over several floors, and then over the interface, over the user interface, you can select a couple of sensors you would like to have for your experiment, allocate them, upload your code, go home, and then after an hour or 2 hours you will get your results by an email, for example, and you also can repeat several experiments during the night, and you do not have to care about the experiment. So it's a very controlled environment, in particular also supporting our wireless sensor network research in order to remotely and autonomously run experiments and also repeating experiments. Okay, the one challenge in this project was that we had several different networks together. That means in Bern we have T-mode Sky sensor nodes, in Lübeck we have Sunspot nodes. That means everybody has his favorite sensor network nodes, his favorite technology. And if you have a heterogeneous environment, of course immediately the requirement comes up that we need to have some kind of uniform interfaces to access all the different heterogeneous infrastructures. And therefore, in our project, we developed several APIs that shall hide the heterogeneity of the testbed infrastructures and also the heterogeneity of the implementations. And since a few research groups are also very active in web services, the proposal was to use web services as a kind of technology for implementing these APIs. So you see here different APIs, and all the APIs are web service APIs. So basically, if you want to reserve sensor nodes, you send a web service call to this reservation API, and then a complete network site is reserved, or maybe only a few nodes of that site. Also, for example, if you want to upload code to the sensors, you send some call to the WSN API in order to upload the code. Of course, these web service calls should then only be available to authorized people, or maybe to software processes which have the right to access these resources. That means we basically have to secure these calls. That means we have to add authentication and authorization functionality to these web service calls, so that such an entity which receives the call at the API can detect whether the user is really authorized to use it. So, for example, whether the user is member of the project, or whether it's some other person somewhere in the world trying to access the sensor network. And therefore, we also implemented basically some API for authentication and authorization, also using web services. Here another picture of basically the portal server, which shows that some different software has been included. So this is basically the portal server interconnecting the wireless sensor network with the internet, and there you see a web server. We see a management interface, and also we see here a software component called Shibboleth here, and that's exactly this authentication and authorization infrastructure developed by the Internet2 Middleware Initiative. And basically we have taken this software as a basis, and also we didn't want to change anything on this software, since this software is also widely deployed in European research networks. I will later show an example. For example, each university in Switzerland is using this software for protecting web sites and web resources. And also Germany, UK, and so on are also using that. So, for example, via this portal server, maybe a command is sent here to this software, authentication is performed, and then, for example, a node can be reset, for example, in order to prepare the node for uploading a software to be run on the sensor network as an experiment, for example. Basically, in our group, we have been responsible for the management software to control the access to the sensor network. So we call our software TARWIS, that's an acronym for Testbed Architecture for Wireless Sensor Network, and there's several functionality integrated in this management system. So, for example, we have to manage the testbed. That means we have to allocate nodes, we have to configure the nodes, or we have to reserve time for performing our experiment. Then nodes have to be selected, and the user code which shall be tested will be uploaded to the sensor node. So first, basically, of course, the user provides the software to this management system, and then the management system will upload the software to the various sensor nodes. Then the experiments have to be monitored. So some users might want to check whether the software, for example, in an early test phase, is behaving as expected, and therefore we need some monitoring interface. And of course, we need authentication and authorization in order to allow only authorized users to manage and access our wireless sensor network testbed. So that brings me to the more security-related part of this talk. And first, I want to introduce or to fix a couple of terms in order that we understand the same under these terms. So basically, we have to implement authentication and authorization support, and under authentication, we understand the verification of a claimed identity, and authorization is the verification of the access rights to resources or to services provided by our system. And a system which combines both authentication and authorization in the following is called Authentication and Authorization Infrastructure. So how could we implement an AI, an Authentication and Authorization Infrastructure? So this figure here shows basically a traditional AI, and we call it also a non-federated AI. So in a traditional environment, we have maybe here several services or resources that shall be accessed by some users. And maybe the most simple thing is that we just combine authentication and authorization at these resources. And that, for example, means that here, for example, we could store a list of usernames and passwords. So in that case, maybe everybody of us wants to access portal lab A, for example, or the center network behind that portal. Then we could here in this part, in this green part, just configure credentials consisting of usernames and passwords. So in that case, if you log in, you have to log in with your username and the password, which is here in this file, and then you get access. Then maybe you also want to have access to network B. Then we have to do the same here. That means again a password or username password file for all the users who shall get access. And then we might have the same here and there. And in the end, if we have 100 different labs we want to access, each user has to be inserted here in each password file, for example. So that's not very nice, and basically that's also the situation today. If we access too many different websites or services, for each service we have an own username password combination, and this ends up very frequently in some stickers on the computers with the username password combination, and probably that's not very secure, of course. And also, of course, it's a management burden. So each partner, each resource provider who wants to give access to others has to insert username password combinations for each user, and think about a system which is being used by thousands or 10,000 of users, and we have 100 labs we want to interconnect. Then we have 1 million of username password combinations to be managed, and that's of course not very scalable. So yeah, non-federated AIs have several disadvantages. So we have these credentials. Of course, you could think about password managers where you store your passwords for the different sites, but then you might have the problem if you are working with different devices and this password file is not stored on each device, or even in such scenarios it doesn't help. And of course there is a significant registration and administration overhead for the resource providers, as I mentioned before. So therefore, in the last 10 years, let's say, the concept of federated AIs came up, and a federation basically is a group of organizations agreeing to interoperate under a certain rule set. So in our example, a federation could be the set of project partners of this Wisebed project. Or in Switzerland, we have a federation consisting of all the Swiss universities. So they have agreed on certain rules. They also have some kind of trust relationship. That means they trust each other. So if some message comes from a resource at University of Bern to ETH in Zurich, ETH Zurich trusts what the Bern server provides. So there is a trust relationship in this federations, and also we have to agree on certain information which are exchanged, in particular user attributes, as we will see later. So in the system we have used, each user has an attribute set which is stored at the home organization. So for example, for me, it could be stored that I'm a computer scientist, that I'm a professor, and that I'm above 40 years old or so. So these could be attributes stored with each user, and later the attributes could be used for deciding whether to give access to a user or not. That means that's also a feature of federated AIs, that the authorization later can be fully based on attributes. So for example, we can specify at the wireless center network in Bern that all the project members of Wisebed are allowed to access the resource. So that could be just a single entry in a file, and if many different users are trying to access, then they have to provide their attributes, and if the attribute set contains Wisebed project member, then the resource allows to access the wireless center network. And if a user comes and does not provide the attributes, then maybe the access can be prevented in that case. So in a federation here, each organization which is a member of this federation is assumed to run two kind of entities. Basically, first we have to run so-called identity provider. So that's basically used for authentication. So identity provider is a server where all the users of our organization are listed, and all the attributes are also stored in that identity provider. So for example, at the University of Bern, it could be a system where for each student, for each teacher, we have entries with a username and the attributes. For example, the subject the student is studying, or the age, or any other things we might want to use for later authorization. So typically we have one identity provider for each organization in that case. And then we have, for each resources we want to protect, for example, for each web server or for each center network, we have to run a service provider. So if we have 10 websites to be protected, then maybe we are running 10 service providers. And the service providers are basically the components or the entities which are finally deciding about whether to grant access to a user or not. And as I mentioned, that could be done based on a user identifier, for example, but it could only rely on an attribute, and that makes the whole thing very, very scalable. So in that case, organizations, they have to maintain this database on the IDP, and the resource owners, they have to define the access rules. That means we have here in the system a clear separation between authentication and authorization. Authentication at the home organization where the student is registered, and authorization at the owner of the resource. That's a very clear separation, and it is not mixed up as we have it in many systems today, where authentication and authorization is mainly at the resource integrated. So basically that's shown here on this slide. So on authentication, basically here at the home organization of the user, authorization at the resource. And also you see here that the resource does not have to care anything about maintaining user credentials, for example. So federated AI has several advantages. So in particular for the user, it's becoming much more convenient. The user only has to authenticate against the home organization, and therefore it needs only a single password if we have a password-based authentication. On the other side, it's even up to the home organization to decide what kind of authentication mechanism should be supported. So of course, username password is quite widely used. And also the resource providers only have to do not have to manage credentials, but only manage their resource, and therefore the task for the resource providers can be simplified significantly. Another issue concerns privacy. With the systems which are already deployed, it might even be possible that users define exactly what kind of attributes are delivered from the home organization towards a service provider. That means the user could, for example, define that the attribute gender shall never be delivered to any other entity, and therefore could control what kind of information is given out to external partners. That's, I think, also a very nice feature in terms of privacy issues. So for our system, we have taken this Shibboleth software. So it's a open source software package for web single sign-on. Has been developed in the United States by the Internet2 Middleware Initiative, but has been deployed by many European national research and education networks. That means the network providers providing connectivity to the universities in Europe. It's typically based on password authentication, and together with the Internet2, some research networks got an award 2 years ago. However, and that was a limitation for our use, since we wanted to support web service authentication and authorization. The Shibboleth software only supports authentication and authorization of access to web pages and not web services. That was a limitation we had to overcome. And maybe at this point, I just want to show you an example how it works instead of just using this file. So basically, what I do here is I go to a service from the Swiss research network where I can reserve a video conference facility. And so I just try to access this web page which is managing this video conferencing stuff. And now I'm redirected to my home organization. That means I have tried to access the Switch video conferencing web page, but then it has redirected this access to University of Bern. I have already provided information that I'm from University of Bern, and then I just log in here at University of Bern. The authentication is performed, and after successful authentication, I'm redirected again to the initial resource and can, for example, schedule a video conference for tomorrow. So not everybody shall use that service, but I'm authorized to use it. So that's basically this figure where I want to access a web page. I try to access this web page, then I'm redirected to a discovery service. The discovery service detects that I'm a member of University of Bern and then redirects me to my home organization for authentication, and after successful home authentication at the home organization, I'm redirected again to the resource. That's basically what I have shown in this example. The problem, however, is that this Shibboleth system only supports protection of web pages, but not web services. And in our Wisebed example, I showed you that we wanted to provide access to the resources using web service calls. Also, that, for example, you might have somewhere a process running which is able to allocate different test beds simultaneously, and in that case, not always a user is able to type in passwords and so on, as you have typically in a web-based environment. So we looked for a way how to use this web-based or web page-based Shibboleth software for web services. And the requirement was we did not want to to change anything on this Shibboleth AI. That means we wanted to keep it untouched so that we can use also existing deployed software in our networks. So how did we manage this problem? So basically we introduced a concept based on a temporary authentication key for machine-based authentication. That means machine-based authentication is when the whole procedure does not have any user interaction, where maybe running software processes shall perform the authentication. That means no user might be involved here, so that the complete process can run automatically without any user. So in our concept, we implemented now an authentication web service where a user can provide, or a software process can send a request to that service. For example, also giving some credentials, username, password, of course encrypted in that case. And the authentication web service then returns a temporary authentication key to the user. And then in the next step, the user wants to call another web service, for example, in order to reserve the sensor network testbed. And then these web service calls, they should carry this temporary authentication key provided to the resource or to the web service provider. The web service provider will then be able to derive from this key, since we have extended that key by the home organization of the user, where the home organization of the user is, contacts then the home organization with this temporary authentication key. The home organization is then able to take this temporary authentication key and look in its database what kind of user is using this temporary authentication key, and based on that information the IDP can then provide the attributes of that user to the resource, and the resource takes the attributes, for example CS student in Bern, and based on that attribute it can decide to grant access to the testbed or to grant no access to the testbed. So that's basically our concept here. You see the different steps in the whole procedure. So first we have to authenticate the client. We give the credentials, of course, that has to be encrypted, for example using SSL, and then the authentication key is given back to the client. And then we have the final web service call, for example, make reservation in order to reserve a testbed, for example. And you see here the authentication key is given and some reservation parameters to describe maybe which sensors to be reserved, for example. Then the reservation system, which gets this call, asks the home organization and just provides the authentication key. That's the information it has. The home organization has issued the authentication key and can then look into the database or what kind of user is behind that authentication key and can provide the user attributes. And then the reservation system receives the attributes, asks a local resource authorization system where some rules are described, for example, which kind of users are allowed to access the resource, and then a yes and no decision is given back, and the reservation system just can give access to the user or can decline the access offer of the user. So that's basically some implementation details. Basically, what we have done is we have implemented here in the authentication service a web or an HTTP client which receives the authentication request, then performs the authentication. Basically, as a human user would do it using a web page interface. So basically, we are simulating here a user by this HTTP client, and by that simulation, we can completely keep the whole system here unchanged. Then the whole process still is based on HTTP requests and redirects and so on, so that the whole system remains unchanged, and finally we can give the result back here to the client. And also here in this case, where the final reservation call comes in or is issued here by the client, so here we might have the call to make a reservation of a test bed, and the SOAP server receives that request and then starts a Java client, which basically again simulates all the procedure which has before triggered by a web browser driven by the user. So using that system, we have implemented a couple of web service calls, and basically we have two user interfaces, and I think time permits to show these two user interfaces. So first a web page based interface using the normal Shibboleth system, and then an iPhone app using the web service calls. And basically for our reservation system, we have implemented here 5 calls. So a get reservation call, which just lists the currently active reservations of other users, so that the application can display at which time which testbed is available and when not, or a single or particular user could just display his own or her own reservations with get confidential reservations, or maybe a get reservation can return the details of a particular reservation, and then by make reservation we finally reserve a testbed or a subset of nodes of that testbed, and also we can delete a reservation. So instead of showing the system on the slide, I try to do it again live. So I access now our portal server with the address gridlab23 at Uni Bern, and then I'm already redirected to the so-called directory service, where you from server. That means here you see the different partner organizations of the Wisebed project, and now I have to provide the information that I am registered at University of Bern, and then I'm redirected to the IDP, to the authentication server of our lab. I have to provide my credentials, and then I'm forwarded again to the resource I tried to access. That means to the reservation server. And for example, I could here allocate a couple of nodes in this time table. Okay, so that's basically the web interface we have implemented, but that system now only used the plain Shibboleth system. That means a system which protect or tries to protect web pages using this software. As a proof of concept for our web service calls, we have implemented an iPhone app, and maybe if the technology works, we can switch to the other display. Is that possible to put it? That means to.
Okay,
Yeah.
Yeah.
Okay. He's doing it. It's
Okay.
all right.
Okay. So in that case, we have implemented here an iPhone app, and this iPhone app now only issues web service calls. So here, for example, again, I can provide my identity, or my home organization can provide my username and password, and then I authenticate. That means now I'm sending a web service call to the SOAP server, and then the SOAP server takes this call and performs all the Shibboleth procedures by implementing an HTTP client, basically. And then I also can reserve a testbed, for example. No, not maybe the whole day, otherwise my students cannot work anymore. So I just reserve it for the next 3 hours, since it's already 11 o'clock in Switzerland, so it's probably they don't work. Can provide or can select our testbed, and can maybe select a couple of nodes here and make the reservation. And now again, only web service calls are exchanged between this application and the server in Switzerland in order to reserve the resources. Yeah, maybe I can now go back here. Okay, yeah. Now you see here the reservations I just have done. So that's again the web interface, where you see here these blue blocks, and which indicate that I have reserved the nodes. I also can reserve some other nodes here via this web interface. Okay, so that brings me already to a summary or conclusion. Though we have implemented here a system based on this Shibboleth Authentication and Authorization infrastructure for this federated testbed environment to support both user and machine-based authentication, one using web page access to the services provided, and the other one using web service calls. And the challenge, as I have mentioned, was that we should do that without any modifications of this Shibboleth AI. Of course, you could maybe claim that it's a little bit a hack, that maybe a more clean solution could look a little bit different. And since I'm not a security expert, as many of you, maybe I'm able to learn a little bit from you. But in particular, it made our life rather easy. So in our case at Bern, we just had to add a single line of a configuration file, and just giving all our colleagues in the project access to our testbed. And for example, if we would give computer science students at Purdue access to our testbed, and you would also be connected to this AI, we just have to add another line saying that all the CS students in Purdue are allowed to experiment with our testbed. And therefore, I think it's rather scalable, since the resource providers, they do not have to care about usernames and passwords. They really can focus on the resources they provide. The users only have to memorize one single password. They do not have to be afraid of managing different passwords. They also can control what kind of attributes are delivered from the home organization to the resource providers. And I think, therefore, there are many advantages for all the involved people. So that concludes my talk, and yeah, I hope to receive some questions or comments or remarks, or maybe also proposals for improvement. If you want to have more information, please go to the websites. Thank you.
Okay. So I think these ideas could also be used for cloud computing, authentication, and authorization.
Exactly. I think this whole federated AIs, they have been proposed during the last years, in particular for grid computing, where we also have distributed resources, where we have many users trying to access the distributed resources. Okay, now we are not talking anymore too much about grid computing, but cloud computing, but the problems remain the same. We have several distributed resources and which have to be managed, that means in terms of access control.
Is it possible that you try to use a web service and the web service needs services from other service providers, and it could automatically cascade your authorization without you getting authorization from everybody?
Yeah, I think that's a good idea. Basically, yep, that was even in our plan, but we did not. Other partners did not yet implement this system. So what you could think about here, for example, that we have here different labs where resources have to be allocated, but the user might not be interested to care about where the sensors are, whether they are in Bern or Lancaster or somewhere else. So the user could just go to a global reservation system, and the global reservation system could then contact the individual networks and try to find out where are enough resources, and or maybe also allocate several sensors at different sites. For example, also people have implemented virtual links in order to interconnect the sensors over tunnels that you can even distribute your experiment. In that case, you provide your authentication key here, and the global reservation system just forwards it to the other service providers. And that's basically an example where you have one compound service which is broken down in various sub-services, let's say.
Thank you.
Do you have any other questions? I have one. Your system is sort of like Kerberos, except that it is web-based. Are there any other differences between your system and Kerberos?
Okay, now I have to remember a Kerberos. I think one issue is the
Tickets?
the attributes, basically. I think that's one key difference, that you are not bound to particular users, but you easily you can define attributes. So, for example, all CS students from Bern are allowed to access this and that. That's, I think, one difference between these two systems. Yeah. But Kerberos was also under discussion at the beginning when we designed this system, but due to several advantages, and in particular, it's deployed in Switzerland for other services which are protected. For example, Microsoft provides software for students for free, and our students. They are connected to this AI, and Microsoft has implemented a server which just checks whether a student is registered at the university, and Microsoft trusts the university if the university provides a certain attribute that it's a registered student, and then the student can access the Microsoft server. So the Microsoft does not have any lists of students or usernames. They just accept our attributes and then grant access to the students. Also, several libraries are also beginning to deploy this system. For example, many libraries just do some kind of access control based on IP addresses. When I'm in Bern and try to access an electronic library, then the access is based on the IP address where I'm from. When I'm here and you do not have maybe that agreement with the library, I'm not able to access the library, but with such a system I can provide my attributes again and can access the library, for example. So it does not have only academic use, but more and more commercial use too.
Do you have, how many users do you have?
If I'm a marketing guy, I would say 200,000. But since each Swiss university is connected to the system, each Swiss student is automatically counted as a user.
Okay.
But in our case, also internally inside the university, this system is used. So
can your system, based on attribute, whether it's a faculty or a graduate student, undergraduate student, give preference for reservation and maybe cancel reservation for somebody?
Not yet.
Okay.
We could implement that.
But that's the advantage of the attribute, right?
Yeah, for example, we could say that if I have a reservation, for example, for demo purposes here, and a student of mine comes and wants to do real work, then he should get the priority. That would be possible. Yeah. Good idea.
How long did it take to do this, and how many students were involved in finishing this project?
Okay, the nice thing is we have reused this Shibboleth software. I would say that approximately one person a year to implement the things around. And also, it's not too easy to set it up, and since also many users they do not have this thinking that authentication and authorization are two separate issues, should be separated. Even in our project, where mainly computer scientists have been involved, we had to do a lot of education in order to teach that paradigm. So it's not really it's not quite easy to understand at the first moment, and several partners did not succeed also to set up such an authentication server. So in that case, what we did, we just set up an authentication server at Bern, so a kind of cloud service, basically. And also our Swiss research network provider, they are offering authentication services in their cloud for small universities which do not have the resources. So that's also a very nice example as a cloud service, this authentication issue.
Thank you.
Okay. Let us thank our speaker.
Thank you.